Tonight, what we're going to be talking about is how to predict the products for a given reaction. Now, this, I believe, is the hardest part of this entire chapter. So everybody go into your backpack, take out your thinking caps, put them on, and here we go. So there are a few hints to predicting products, but in the end, you just need to practice it and be able to identify these by looking at it. The one tip that I would recommend, though, is first you look for those combustion reactions. How do you identify a combustion reaction? You're going to look for some sort of hydrocarbon, so a carbon-hydrogen combination. Now, you might also have an oxygen attached to it, or an alcohol attached to it, which would make it a hydroxide looking, but some sort you have to have that C and H together in the same compound. You will also look for that oxygen as a separate one. So you'll have CH of some sort plus O2. Now, whenever you have identified this as a combustion reaction, the products are always CO2 plus H2O. These are the best ones to be able to predict the products for because they are the easiest because they're always the exact same. Then what you want to do is after you've identified all the combustion reactions, you want to look for something that has a single compound as a reactant. And that's it. Like it doesn't have an element, it doesn't have anything else, but it has a single compound. Instantly identify this as a decomposition reaction. If it is not a combustion or a decomp, you only have three left. You have single replacement, double replacement, and synthesis. So what I would recommend is you kind of label in your heads elements and compounds. And then if it's two elements, it's going to be guaranteed to be a synthesis. If it's an element plus a compound, it might be a single replacement. And if it's a compound plus a compound, it's most likely going to be a double replacement. There are some exceptions though. If you ever have something plus water, plus carbon dioxide, or some sort of chloride plus, and this is a metal, so metal chloride plus oxygen, you are actually going to have a special synthesis reaction. So look out for those three guys. Okay, so water, carbon dioxide, chloride, plus an oxygen. Then you want to identify the type of reaction. From there, you're going to predict the products following the pattern. So a synthesis will just smush them together, a decomp will break them apart, a single replacement will have the metal kick out another metal, or a non-metal kick out another non-metal, double replacement will switch the two metals or the two cations, and a combustion will always produce carbon dioxide and water. Then if you created an element as a product, you have to worry about your Hankel-Briefs. Okay, what do you do if you have a Hankel-Brief? You're going to write as H2 or O2, you're going to put those diatomic molecules together. If you create a new compound, most likely you're going to have to worry about those charges. If it is an ionic compound, you will always be worrying about charges. And typically in this class, we deal with a lot of ionic compounds, so you'll tend to be thinking about charges a lot. After you have predicted all this and stuff like that, worried about the charges, worried about your Hankel-Briefs, then your last step is to actually balance the reaction. So these are the special synthesis reactions that you are going to have memorized. You will have already received a sheet with these on it, or you will be receiving a sheet with these on it, just so you can kind of get in the handle of understanding these. If you ever have a metal plus oxygen, so it looks like this, metal plus oxygen. So if I were to label it, I would be an element plus an element. It makes sense that it would go to smushing them together and you would get a compound. So this would be a classic synthesis reaction. Same with the next one, where you have a non-metal plus oxygen and you're just going to smush them together to make a non-metal oxide. So what you're going to have is an element or a non-metal plus oxygen. So look at, you have an element plus an element. The only thing that these two things can do is squish together and make a compound, which they do. Okay, so these so far are not anything special. These guys, okay? A metal oxide plus water. This is a special one. Okay, and what you have to do is as soon as you see that water, you're going to be like, bing, 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 bing. Oh, this might be a very special synthesis reaction. And so what you're going to do is you're going to have this metal oxide, and it's going to combine with water. And all you're going to do is smush it together to make a metal hydroxide. So in this synthesis reaction, you identify the metal, which is magnesium, and then I'm going to make magnesium and I'm going to combine it to make my hydroxide. It will always form, if you have a metal oxide, so metal plus oxygen plus water, it will always squish to make this metal hydroxide. And as soon as you make this metal hydroxide, you identify the metal, and then you're going to worry about charges. So magnesium has a +2, OH has a -1, so when you crisscross it, that's how you get that MgOH2. A non-metal oxide is going to be some sort of non-metal, so to the right of the staircase plus oxygen. So here SO2 would be an example because S is a non-metal, plus water. What you're going to do is you're going to squish them together and you're going to make an acid. For this class, all we're going to do is actually add up all these guys. So I have H2 and then I have one S. So I'm going to put S, and then I have 2 O's from this guy and 1 O from that guy. So I'm going to make it H2SO3. So this would be the acid I form. So if you ever have a nonmetal oxide plus water, just kind of squish them together to make your acid. Make sure you put that hydrogen first. Okay, then the next one we see is for synthesis special is this metal plus non-metal. So a metal would be anything to the left of the staircase, a non-metal would be anything to the right. So sodium plus fluorine. If I looked at this, this would not be a special really synthesis reaction. Why? Because I have an element plus another element and I'm going to form a compound. So this is just a typical synthesis reaction. A metal oxide plus carbon dioxide. So if I were to label this, here's my metal, here's my oxide. Why is it an oxide? Because it has that oxygen plus carbon dioxide. So if I were to originally have labeled it, I would have labeled this as a compound and another compound. So what would I think? Oh, double replacement, because a compound plus compound typically is going to be a double replacement. But in this case, if you look at it, this C is also a nonmetal, so it will not follow that typical double replacement reaction. Instead, bing, 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 it's got this carbon dioxide. So you're going to want to make sure that you're thinking about this as far as these exceptions that look for that chloride, look for that water, and look for this carbon dioxide as far as the reactants go. And what you're going to do is you're just going to make a metal carbonate. So what is the metal in this reaction? It would be Pb. What is a carbonate? CO3 with a -2. Now I need to look for what my lead charge is. Now in this case, I don't usually have this because I'd be predicting the products. So what I'm going to have to do is look at this PbO. O has a -2 charge, so in this case, Pb has a +2. So I'm going to assume that it's going to stay the same charge, so a +2, so that's where I got that PbCO3 as its product. And then we've got that metal chloride plus oxygen. How do you identify that this is going to be that synthesis? Well, we have that chloride with a metal plus oxygen. So this is a bing, bing, bing exception. And all you have to do for this one is you're going to make your metal, which is in this case is copper with a +2 charge. Chlorate is ClO3 with a -1. And when you crisscross, you get Cu, ClO3, 2. So this would be the exceptions, the 7 rules, I guess, the 7 types of synthesis reactions that we'll be dealing with in this class. The only exceptions are this guy, and these guys. Okay, so you see those waters, carbon dioxide, and oxygen. The decompositions are the exact opposites, so I'm just going to do one of them. If you look at this metal carbonate, okay, it would be easy to identify because it's the single compound by itself. The only thing it can do is break apart, but in this class, you're never going to produce like 3 different products. The only thing we're going to do is we're going to split it up and it's going to form into a metal oxide plus carbon dioxide. So if you ever see a carbonate, it's going to produce CO2 and then a metal oxide. So this is the metal oxide plus your carbon dioxide. So let's just try to predict some products. This page will primarily be the ones that are not the exceptions. So first I'm going to look for a combustion reaction. I'm going to go through all of these and this is the only combustion reaction I see. How do I know? Because it has that hydrocarbon plus oxygen. So knowing that, I'm going to form my products of CO2 plus H2O. Okay, I can kind of skip all these because I've already done it, predicted my products. Don't have to worry about my Halkoberiffs in this case because it's just the exact same product all the time. Don't have to worry about the new compound or charges. So now I'm going to balance the reaction. So if I look at this, I need to balance my carbons first. They're already balanced. I'm going to balance my hydrogens next. So I put a 2 in front of there to make me have 4. And now I have 2 oxygens on the left and I have 4 on the right. So I'm going to put a 2 in front of that oxygen. So it goes 1, 2, and then my products are CO2 plus 2 H2O. All right, now let's try the next one. I've got my combustion reaction already checked out, so that's that guy. Now I'm going to look for a single compound as a reactant. So first guy has 2 compounds. The second guy, oh, look at this, MgBr2. So this is going to be my decomposition reaction. If it is not, I'm going to label that element compound blah, 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 blah. But it is. So now I'm going to identify the type of reaction. So now I'm going to predict the products. This is just a metal and a non-metal. Okay, so all they're going to do is break up into their individual elements. So I've got magnesium plus bromine. Okay, now I've predicted my products. They are going to separate into their individual elements. Have I created an element? Yeah, I've created 2 elements in my MG and my BR. So now I just have to worry about my Hunkelbriefs. Is MG a Hunkelbrief or is BR a Hunkelbrief? Well, BR is a Hunkelbrief, so we're going to put a 2 there. I do want you to note that just because the 2 was on the left-hand side for the reactant side, that does not mean that that's why the BR has a 2 on the product side. It is a totally different thing. I had to rethink about it. It's not worrying about charges, it's worrying about those Hunkelbriefs. That's why it has the 2 on the right side. And the reason why it has the 2 on the left side is because MG has a +2 charge and BR has a -1. So when you crisscross, you get that MgBr2. Now I'm going to worry about balancing my reaction, and it already is balanced. So it would be MgBr2, arrow MG plus BR2, 1, 1, 1. All right. So now I've done this guy and this guy. So the next thing that I'm going to be doing is I've already done all these. So now I'm going to label my elements and compounds, and I'm going to look for anything with plus water, carbon dioxide, or this weird chloride plus oxygen. All right, I don't see any of those carbon dioxides or waters, and I don't see any chlorides plus oxygen. So all I'm going to do is worry about my elements plus compounds. So I've got my compound here, I've got a compound here. Got an element here and an element here, and then I've got a compound plus an element. All right, so the one where it's a compound plus a compound and it's not one of those synthesis exceptions is going to be a double replacement. So now I've identified the type of reaction. Now I'm going to predict the products. The products for a double replacement is when you have the first element, you are going to switch it with the first element of the second compound. So now I'm going to write Ca, and it's going to literally take the spot of where H was, and H is literally going to take the spot of where Ca was. So it's now going to be HCO3 plus CaCl. Okay? So now I've combined my products. I do not have any elements by themselves, so I do not need to worry about the Hunkelbriefs. I did create a new compound, and they are both ionic compounds. So now what I have to worry about is my charges. Hydrogen has a +1, carbonate has a -2. So when I crisscross, I'm going to H2CO3. Ca has a +2, Cl has a -1. So when I crisscross them, I'm going to get CaCl2. So now that I've created my reactants and my products, I now am ready to do my final step of balancing. All I need to do is put a 2 in front of my HCl, and I am balanced. Let's try the next one. So I've already gotten down to this step. Okay, and I know that I don't have any weirdo ones, so now I need to identify the type of reaction. So if I have an element plus an element, that has to go into a compound. So this would be a synthesis reaction. Why does it have to go into a compound? Because the only thing that they could do is squish together if they wanted to be any sort of different thing. Otherwise, it wouldn't be a actual chemical reaction. Instead, it would be just a physical change. So what we need to do is we're going to combine Na with O. So I'm going to be making a compound. So I put my metal first and then my non-metal. So it's NaO. Notice I did not carry over any of those subscripts. Why? Because I'm creating a new compound. So now when I'm creating a new compound, I have to worry about these charges. Na has a +1, O has a -2. So when you crisscross, you get Na2O. Now I'm ready to do my last one of balancing the reaction. So I'm going to put a 2 in front of the Na to balance that out, but that did not work. So now I'm going to worry about my oxygen. So I put a 2 in front of my Na2O in order to balance my oxygens of 2, and now I'm going to need to put a 4 in front of my Na on my reactant side. So it goes 4Na plus O2 goes to 2Na2O. And now I'm on my final reaction where I have a compound plus an element. In this case, I know that it is not a weirdo synthesis reaction, so I know that Na is a metal and it's going to kick out its like, which is the other metal. So now Na is going to combine where Pb was, and Na is going to hook up with NO3. And then now Pb is going to be kicked out, and it is all by itself. So when I created this new compound of NaNO3, I need to worry about my charges. Na has a +1, NO3 has a -1, so when you crisscross, they cancel. Pb is an element by itself, so I have to worry about those Hunkelbriefs. It is not one, so I leave it. Now all I have to do is worry about balancing. I have two NO3s on the left, so I'm going to put a 2 on the right to make my NO3s on the right too. And so now I need to balance out my Na, so I put a 2 in front of that. All right, so those were the basic ones, which will be primarily most of them, but there will definitely be a lot of these special synthesis and decomposition reactions. So first we're going to look for a combustion reaction. I don't see any combustion reactions in there, so this whole step is out. Now I'm going to look for a single compound as a reactant. This is the only one, the second guy is the only one that I'm going to that has a single, oh no, this one does too. So these both have the single ones by themselves. Okay, so I know that these both are going to be decomposition reactions. So I'm going to look at my handy dandy thing. So a lot of people would be like, oh, well, it's a decomposition reaction, so it's going to be forming Ca plus C plus O. No, that's not how this class goes. Okay, we're going to be making two things from a decomposition reaction. So this is one of those specialty ones. So what it's going to make is it's going to form a metal oxide. So the metal in this case was calcium, and it's going to form an oxide, and then you're going to form carbon dioxide as the other product. Now I need to worry about my charges with my metal, with my metal oxide. So Ca has a +2, oxide has a -2, so those cancel. So I do end up with CaO plus CO2. Okay, now balancing, it is already balanced. I'm going to do the other decomposition reaction, and so once again, it's not going to form Ca plus Cl plus O because it's not going to form three different things. So I need to figure out what those two different things are. So I'm going to look at my handy dandy little cheat sheet for right now until I'm very comfortable, and I know that a metal chlorate will form a metal chloride. So my metal in this case is calcium, my chloride is just Cl as it always is. Now I have to work and plus oxygen. Okay, so I've got my metal chloride plus oxygen. Now I need to worry about my charges. So Ca has a +2, Cl has a -1, so when I crisscross, I get CaCl2. So now balancing it out, I have one Ci on the left, I have and I have one on the right. I have two Cls on the left, I have two Cls on the right. I have 6 O's on the left, I have 2 on the right, so now I'm just going to put a 3 in front of here, and I am completely balanced. All right, now I've gotten through all my decomposition reactions, and now I'm going to look for any of my elements and compounds. I'm going to look for that water, carbon dioxide, the metal oxide plus oxygen, or metal chloride plus oxygen. In this case, I see water. So I know bing, 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 bing. Oh, this is going to be one of those specialty synthesis reactions. So I'm going to go to my handy dandy specialty synthesis reaction sheet, and it says when you have a metal oxide plus water, what you're going to make is a metal hydroxide. And what is a metal hydroxide? Well, hydroxide is hydroxide, so that's OH with a minus. The metal in this case is K. So when I combine K plus with an OH minus, I'm going to get KOH as my product. So now knowing that my product is KOH, I am going to balance my charges out, or I'm going to finish balancing my reaction because I've already worried about my charges and I don't have any elements by itself. So now I've got 2 K's on the left, I need to put 2 K's on the right, so I put a 2 in front. I have 2 H's on the left, I now have 2 H's on the right, I have 2 O's on the left, I have 2 O's on the right, and there we go. So what I do want you to notice about all of these reactions is I'm going out of order. Like I'm not doing them necessarily in order, especially initially. Now when I'm doing it, I go through all of these steps at one individual time. For you right now, it's probably a good idea just to chunk them. Like look for all those combustion reactions on a worksheet, do all of them. Then look for all your decompositions, then do all those. Then go back and do all these specialty ones and so on and so forth. It's probably better to chunk right now, and then when you get a lot more comfortable, then you can kind of go through all of these like different steps in your head at one individual time. All right, tomorrow we will be starting to practice these, so hopefully you have a basic understanding and you're going to have so much fun, trust me, tomorrow.